So hello and welcome back to Genknown tutorial, and for today's video we will going to talk about the Pythagorean relations. But before we proceed, please don't forget to click the like button, hit the subscribe button, and also hit the notification bell for you to be notified in our latest and future uploads. At first, we have this Pythagorean theorem. We have h squared is equal to the adjacent squared plus the opposite squared, where the h here is the hypotenuse. This equation came from the Pythagorean theorem. And today, I'm going to show you how these following terms or trigonometric terms becomes 1, -1, and 1. So take note also for our first topic, which is the function of the right triangle. So let's try our first equation here. Sine squared theta plus cosine squared theta is equal to 1. Sine squared theta plus cosine squared theta is equal to 1. Remember the SOHCAHTOA, the mnemonic SOHCAHTOA. Under the SOHCAHTOA or under the SO, we have sine theta is equal to the opposite over adjacent. So let us substitute that with the sine squared theta. So sine squared theta is just equal to the opposite squared over the hypotenuse squared. So that is equal to the sine squared theta is equal to opposite squared over the hypotenuse squared, plus the cosine squared theta is from the cosine squared theta is equal to the adjacent squared over the hypotenuse squared. So let us substitute again. We have a squared over h squared is equal to 1. So as you can see here, in our denominator we have the same variable, which is h squared. So let us factor it out. 1 over h squared. So the only term left is o squared plus the a squared is equal to 1. Remember the Pythagorean theorem. A squared plus o squared is equal to h squared. So these terms is equal to h squared, meaning it has a h squared over h squared is equal to 1. That's why we have this whole number 1, or we have this answer 1. So next is the tangent squared theta minus secant squared theta is equal to -1. So we have tangent squared theta minus secant squared theta is equal to -1. Okay, so from the basic identities, secant theta is just equal to 1 over cosine theta. Since it has a second degree, or it has the exponent 2, secant squared theta is just equal to 1 over cosine squared theta. So we have tangent squared theta minus 1 over cosine squared theta is equal to -1. Again, from the SOHCAHTOA, we have tangent here and cosine. So we will using the ka and toa, where under the ka we have cosine squared theta is equal to the adjacent squared over the hypotenuse squared, and we have also the toa, which is equal to tangent squared theta is equal to the opposite squared over the adjacent squared. So let us substitute these following variables here. So we have tangent squared theta is equal to opposite squared over adjacent squared minus 1 over the cosine squared theta is adjacent squared over hypotenuse squared is equal to -1. So let us rewrite it. That is also equal to o squared over a squared is equal to, okay, this denominator here magiging numerator. So minus h squared over a squared is equal to -1. As you can see again, in its denominators, we can factor out the adjacent squared, 1 over adjacent squared. So the only term left is o squared minus h squared is equal to -1. Again, from the Pythagorean theorem, h squared is equal to o squared plus the a squared. We can say that the o squared minus h squared, okay, transpose this again, is equal to -a squared. So the o squared minus h squared is equal to the -a squared. So -1 over a squared multiplied by the -a squared. Therefore, the negative a squared over a squared is just equal to negative 1. Okay, that's for the tangent squared theta minus secant squared theta is equal to negative 1. Next on the list is the cosecant squared theta minus the cotangent squared theta is equal to 1. Cosecant squared theta minus the cotangent is equal to 1. So under this relation, we have the cosecant squared theta. Cosecant squared theta is also equal to 1 over sine squared theta. Okay, by the use of the basic identities in trigonometry. So let us substitute it. We have 1 over sine squared theta minus the cotangent. We have cotangent squared theta is just the inverse of the tangent squared theta. This is also from the basic identities of trigonometry. Tangent squared theta is equal to 1. So as you can see, we have the sine here and the tangent. So we will using the mnemonic SO and TOA. So again, under the SO, we have sine squared theta is equal to the opposite squared over the hypotenuse squared. And for the TOA, we have tangent squared theta is equal to the opposite squared over the adjacent squared. So let us substitute it again. We have 1 over sine squared theta is equal to 1 over the opposite squared over h squared minus 1 over tangent squared theta is equal to 1 over opposite squared over the adjacent squared is equal to 1. So again, we will, okay, the denominator here in these denominators will become a numerator. H squared over O squared minus A squared over O squared is equal to 1. As you can see again, our denominators here are the same. So we will factor it out. We have 1 over O squared multiplied by the H squared minus the A squared is equal to 1. Again, from the what we call the Pythagorean theorem, we have H squared is equal to the O squared plus the A squared. We can say that the H squared minus A squared, okay, H squared, just transpose this A squared here, this will become negative A squared, is just equal to the O squared. So 1 over O squared multiplied by this term, which is equal to O squared, will give us O squared over O squared, which is just equal to 1. So that's for the cosecant squared theta minus cotangent squared theta is equal to 1. So that's it for today, and please don't forget to click the like button and also hit the subscribe button and also hit the notification bell for you to be notified in our latest future uploads. Goodbye.